Hello. Yeah. After the identification of a lithology, yeah, we know where we have sand, where we have shell. So for example, let's pick an area where we have sand. From this, I think you should be able to identify areas where we have sand. So we have, and you know the reason we have the sand there. Low gamma ray, high resistivity, because sand is not conductive. So that is why, because it has some water in it. So high resistivity. So the resistivity is just like presence of no presence of conducting fluid. So it's higher because we have some fluid that is having a higher resistivity. Because when you want to talk about the resistivity of a formation, the fluid in the formations take a very huge part of the resistivity, either make it conductive or make it resistive. As we know that the oil and gas has a higher resistivity than the counterpart, the saline water or the water. So this could be useful to differentiate where we have oil and where we have gas. So sorry, where we have oil and where we have water because of their conductivity. You might not really differentiate where we have gas and oil because they both have high resistivity anomaly. So that is why we have other logs that can do that for you, which is the neutron and the density cross plot. So here we have high resistivity, which is telling us that there is a fluid that contains something resistive within that formation, within the sand formation, as Shane has already revealed to us that we have a lower shale or lower gamma ray content. That the gamma ray, sorry, not shale, has revealed to us that we have a lower radioactive content. So we have a sand that has a high resistivity fluid within it, which might be suspected to be oil or gas. We are not sure yet. So, but the sonic is not really doing something serious here. So, though it's telling us that it's not really faster. It doesn't really has a faster velocity. So now let's move to the neutron and density cross plot. This is telling us something different because it's showing like a big separation between the neutron and the density cross plot. So this can be a gas effect because gas make some negative overestimation of the density and the neutron also. So we have big effect. It acts as if we have a low density and low velocity, which is just as a result of gas presence. We call this gas effect. So this might be filled with gas based on this bigger separation within the neutron and the density cross plot. So let's look for another reservoir. Yeah, this is another good reservoir. You know why I call this reservoir now? Because we have low radioactive content like low gamma ray. We have high resistivity. Yes, this is telling us another thing. It's telling us that we have low radioactive material, which we suspected to be sand, and high resistivity. The fluid content is quite resistive. So you can see the sonic velocity is not really saying something special. Yeah, so but here we have some anomalous area. We have within the same sand zone, the same reservoir zone, we have two distinct signature here, bigger separation and a lesser separation. So this bigger separation you can see is almost the same with the one I've called gas here. So it's as a result of the gas effect. But here where we have a lower density material, which is oil, higher density material, sorry, because oil is denser than gas, as we all know. So the gas is making it too bogus as if it's lesser, making a big separation between the neutron and the density cross plot. But the oil, based on their density, because it's a little bit denser than gas, so we don't really see the effect. So we assume in this reservoir we have gas, and oil. See the contact here around this depth. So let's look for another reservoir. What was suspected to be reservoir? I think you can tell me that. Oh, okay, we found one around here. So you can see we have high resistivity. The sonic is not really saying something, but here you can see. What could you say around about this? So this might be oil, but basically it has a little bit different density, but it's more of oil because we don't see such big separation within the neutron and the density cross plot. So this is suspected to be oil, but maybe there's variability in the density of the oil. Yeah, so here we have some shell within that reservoir. This is another reservoir where we have high resistivity. Sonic is not really saying anything, but you can see that the separation is not as big as the ones we call in the gas based on the gas effect. So you can assume we have some oils in here. So here we have shell. You can see we have shell. So this is a reservoir. You can see we have high resistivity within the same sandstone area. The resistivity is behaving anomalous. You can see we have high resistivity and low resistivity. What this is saying is we have some resistive fluid and some conductive fluid within that sandstone. So the resistive fluid is suspected to be either oil and gas, we don't know yet. The conductive fluid might be like, oh, this might be brine. This might be brine. Let's say this is water. So we don't know the level of salinity. So let's say water. So here the sonic is not really saying anything. So though it's talking about he's not really talking about the anomalies within the areas to justify the difference between the resistivity. So on getting to this area, you can see we have a separation too, but it's not as big as gas separation. So we can call it, you can suspect oil to be in this area, but the low resistivity in this area, we can't say it's gas that filled oil that filled this area. Due to this lower resistivity, it means we have some conductive fluid around here, which might be water. So this might be like oil and water. So we have oil water contact around this area, oil water contact around this area. So this is how to estimate your fluid. You can see here as well we have some oil. Like here we have oil, and you can suspect to have oil in this area. So I want to quickly go through on the since we've talked about the oil water contact, how to locate that using the resistivity. You can see the resistivity log is the best log to differentiate your oil water contact or fluid contact. Is it? Yeah, you can see this actually reflected, but if we have just this, we might not be able to differentiate that. But see how anomalous the resistivity is here. You can quickly see that, oh, there's difference between this fluid that contained within the reservoir. You can see we have one zones of reservoir and we have resistivity behaving anomalously within the reservoir. So now let me now talk a little bit about the resistivity log, talking about the drilling fluid, the suspected drilling fluid. You can see we have from the scale. You can see we have the can see we have the deeper and the medium, let's say shallow resistivity sensors there. So you can see that the dotted line and the full line they are tracking each other, but the dotted line is a little bit lesser, like the values are a little bit lesser than the. So this means that the drilling fluid is giving a little clue about the drilling fluid that for it to be lesser, it's telling us that because the shallow resistivity measurement, we have a lot of inversion around that area. So the drilling fluid might be mixed with the formation fluid. So it's now telling us the shallow that resistivity that was measured within that area that we have invasion is a little bit lower than the deep resistivity that we measure within the deep area where we have less invasion. So this is telling us that what we have used to drill has some materials that has lower resistivity. So you can see some area even in the water zone where we call water zone, you can see some difference. So it's telling us the drilling fluid might be prime because the resistivity is a little bit smaller than the areas where we have less invasion, even in the water zone. So this is telling us that we have a conductive material to drill, which is more saline, like more high materials, high material within the material. So this might be prime. The drilling fluid might be prime. Yeah. So let me talk a little bit about the volumetric because we know how to calculate the volumetric. What we needed the porosity, we needed the gross rock volume that can be estimated from the seismic and or from other quick look like the slab and every other method. So then the porosity, the water saturation, and the hydrocarbon saturation, which can be estimated from the water saturation. So the water saturation can be estimated from the Archies equation, then which contains the RW, the resistivity of the water, which can be estimated from the clean zone. You just look for an area where you have water somewhere around here. So you can estimate your RT there. You can use that to estimate your RW. So from there, you get all your parameters for the volumetrics. So you get for each reservoir, you use a porosity. You can use the neutron porosity. You can use the density porosity. You can use the neutron porosity based on the methods you want to use. You can read the porosity directly from the log. So depending on the method you want to use. So once you have a porosity, you can estimate your type in either in maybe in gram, in centimeter, in cubic feet, or in barrel, depending on how you want the conversion or the SI units to be. So then the net to gross within each reservoir, you can measure where we have shale and sand. So you can actually estimate your net volume within the gross. The gross is just the thickness of the whole reservoir. Then the net is just those where we have just sand, because we can have some heterogeneity within the reservoir. So just to have the idea of how clean your reservoir is. So you can use that to estimate your type. So thank you very much. See you later.